is a little embarrassing because you can just comment out the request for the permission and it still works. Works in all Android versions. So any app can start on boot regardless of whether or not they ask for permission. And so you can imagine you could combine that with the previous toast in a loop and you would have a phone that would be rebooting every 20 seconds. So then another thing, this one there's not actually a permission for, but another interesting thing that developers of malicious and non-malicious applications would like is to be able to start their app on installation. So you can imagine that you could use this with a couple other attacks. Maybe you don't want them to know that running your applications caused it to reboot, so instead you just reboot 20 seconds after they install the app. Or you could imagine this would be while you're in the Google market and you just finished installing an app and you're kind of used to the fact that an app can't run until you launch it. So you could also maybe pop up a phishing dialog at this point asking for their username and password. And they totally wouldn't see it coming because apps aren't supposed to be able to run until you run them for the first time. So there's not a permission for this, but Google Analytics does this. So this snippet of code here to add to the Android manifest is actually from the Google Analytics for Mobile SDK. And you just throw that in there, and this is to track the refer from the market. So say whether I clicked on some AdMob link or something like that. And then this would send it off to the Google Analytics server. But we don't need to use their receiver. We can just write our own receiver. So here we just just created our own receiver instead of using theirs, and now we can launch on install. But there are some caveats with this. It actually does require a refer to be included in the URL. So you could imagine two main scenarios where that would happen. One, they click on an AdMob link inside another application or on the internet, and you can see there's all this refer data that's attached to it that tells you what campaign it was a part of and things like that. Another way is if they clicked on just any old link in a browser, you could just append your own refer info on it just so that this would happen. However, on Android 2.2 on Froyo, the Android market now always includes refer info, so this now always works. They include refer info of things like in this example, it says that we downloaded it from the Games tab, the free section, and it was row index 34. So it gives you all sorts of cool info, but we can also use it here to start on install. So the next thing that I want to talk about, I like to call the circle of death. And this is basically just a hostile takeover of the UI. So it's pretty simple. You just launch an activity, consume all key press events. So here in the onKeyDown method, we're just returning true, which says we handled this key press. Don't pass it on to anyone else. So this allows us to catch every key press except for the home button and a long press of the home button, which is a shortcut to allow you to switch between applications. So we need to do something else also. So what can we do? We can just relaunch our activity when it exits. Now, unfortunately, it's not as easy as just starting the intent for our activity and its on destroy event. We have to be a little more clever than that because Android detects that and doesn't fire off the intent in that case. So what we can do instead is create a circle of death. So just when our activity is destroyed, we just launch a service, and this service just launches our original activity. So all we have to do, in the on-destroy event, we start a service, and all that service does, start an activity, and then can just finish itself. You can imagine the ramifications here. It's actually a pretty easy workaround to get something like this off your phone. You can actually boot up into what's called safe mode on Android. You usually just hold in the trackball while you're starting up your phone, and all non-system apps aren't allowed to run. So here, I just want to show a quick demo. Hopefully this will work. I know that you guys can't really see this, but Hopefully you'll be able to hear it. So here's an application that I've installed on here, and you can imagine that you could use this in all sorts of different ways, right? You could force someone to pay $5 on PayPal to get rid of this. If I can mash all the keys I want, I can't get out of here. All I can do is turn the screen off, but I'm still here. So let me just pull the battery out there. And once again, you can imagine that it's very easy to combine that with something like the start on boot, and you've created some serious mayhem. But all of this is just kind of for fun. There's not none of that is all that serious. But let's talk about something that might be a little cooler. So let's say there's an application that doesn't request permission to use the internet. Maybe you would assume that it's fairly safe and that it can't contact a server. So you're not so worried about the fact that it's requesting your location or all sorts of other things. You just say, oh, that can't access the internet. I'm not so worried about it. I don't care that it can read my contacts. But just because it doesn't request the internet doesn't mean that it can't exfiltrate some data anyway. So even though its sandbox can't access the internet, that doesn't mean all of the other sandboxes around it can, or most of them can. So you can just ask your neighbor. So the easiest way to do this would be to just pop open a browser and point it at some URL and include some parameters in it. So here you can imagine that you send your latitude and longitude off to some server. But there's a problem with this. It does pop open a browser. The browser would appear, and the user would be like, "Huh, that's kind of strange. Why is there a browser on the screen?" So then the question is there a way that we can do this secretly? If you attempt to pop open the browser and then pop open another activity on top of it, obscuring the activity actually causes the on-pause event to happen, which stops the page from loading. So that won't actually work. We have to do something a little more clever. So how about we only pop up the browser when the screen is off? Your screen is off for, 16 hours a day anyway. It's okay if we only get internet during those times. So let's say, so there's a couple things that you need to keep in mind here. You need to be able to close the browser when the screen turns back on. And you probably want to redirect to a safe URL so when the user does launch their browser again later, they're not on some weird page. So here's the basic code that does that. You just ask the power manager if the screen is on. If it is, or if it's not, then you send off data to some server. And if it is on, then and the browser is displayed, then you launch the home activity. So you just send an intent to launch the home screen. You don't even need to kill the browser because that would actually require some permissions. We can launch the home screen for free, no permissions. So this is cool, and it allows us to send data out from our application, even though we haven't requested permission to do so. But what if we want to be able to receive a response too? So what about two-way communication? So there's a couple approaches here. The simplest would be to just pop open a browser to a page with a downloadable content type. So we just send it off, point it at this zip, downloads it, it puts it in the SD card downloads directory. Anyone can read the SD card. There's no permission to do so. But there are some downsides here. One, it creates all these notifications. So if you put your phone in your pocket and you pulled it out later, you'd have like 800 notifications or something like that. Then the other thing is that it creates all of these. It actually creates all of these files on your SD card. In order to clean that up, you need to request the write external storage permission, which isn't actually that big of a deal. Because if your target SDK is 3, that permission didn't exist yet, and you automatically request it. So if you go through the market, a lot of applications request this. So I think most people just tune this permission out. But I think we can do a little better. So how about a custom URI receiver? So Google Maps uses the geo protocol. They just register on this geo protocol. So like geo, latitude, longitude. If you click on a link that's of that format, it pops open the Google Maps application. Now we can do the same thing with our application with no permissions. So we just request the NetHack scheme. So the NetHack protocol, the host here is data, which is basically another way to think about this. If this was the YouTube activity, the scheme would be HTTP, and the host would be youtube.com. And that allows it so when you click on a YouTube link inside the browser, instead of showing you the web page, it pops open the YouTube app. So what we would do on the server side is we would just redirect that page that we're pointing the browser to something like NetHack, data, and then append any additional information that we want to the end of it. Now, I'll note that this is actually an activity and not a receiver, even though we're using it like a receiver. The reason why is because activities are meant to be things that happen in the foreground, and this is meant to be used for something that happens in the foreground. This is supposed to be you click on a link or something like that. It's not supposed to be a page redirecting while your phone is off in your pocket. So here's just the basic receiver code, the receiver, because it's actually an activity. We can just log the URI and you see all the data that's associated in it. The data is available on the intent. This activity is actually, it's not seen as long as we call finish inside the onCreate. We've never created anything on the screen. The user doesn't know anything's up. And even if they did, their phone's off in their pocket. So once again, same caveat from before. You probably want to send the user to a safe page afterwards, so when they open their browser, they don't see something funky. So let's see if it works. So on the top here, I have my Apache logs. I know this is dangerous to be showing. And on the bottom here, I have ADB logcat output for my emulator here. So as you can see on the Apache logs, nothing is going on. And then if let me go to the home screen. If I turn the screen off, and I'll note that the emulator, this is as off the screen gets on the emulator, but really this would be a black screen. We can see here already that there's some activity happening in logcat down here, and we've got data. We are so that's the upload. That's the upload, and then let's see if we got the response. And here we go. There's the response. My secret. So there you have it, two-way communication with an app with zero permissions. So now that I've told you all the cool stuff that you can do with zero permissions, I'm going to turn it over to Tim, who's going to tell you lots of cool stuff you can do with just one permission.
How many of you guys have written Android code before? All right, so I'll try to go through the intro here pretty quickly, but this is a typical example of how you write data to the system logs. Most applications are doing this, and it's relatively simple. It's an easy to use framework, and this is how we debug a lot of stuff. So there are actually four different log devices that are available on a typical handset. In fact, up until 2.2, there were 3, and now we've seen the appearance of a 4th in 2.2. So devlog events is not the main application debug log. This is actually supposed to be for diagnostic events that are typically used by integrators or people working on the core system. Devlog radio is actually a lot of, you typically see a lot of radio command stream data flying around in here, and also some interesting events about registering and unregistering from networks and that kind of stuff. And then we have devlog main is actually where your typical,